In 1999, a spacecraft worth more than $300 million vanished without a trace. Not because of an explosion or a system failure, but because of a simple math mistake. This is the story of NASA's Mars Climate Orbiter and how one small conversion error destroyed an entire mission. The Mars Climate Orbiter was launched in December 1998 as part of NASA's Faster, Better, Cheaper initiative. It was designed to photograph the Martian atmosphere and relay data from the upcoming Mars polar lander. Built by Lockheed Martin, the probe represented years of planning and $327 million in funding. At first, everything looked perfect. The launch went smoothly, and for 9 months, the spacecraft cruised toward Mars exactly as planned. But as it approached its destination, the navigation team at NASA's Jet Propulsion Laboratory noticed something strange. The data from the spacecraft didn't match their predictions. Each small course correction seemed stronger than expected. The numbers were slightly off, but no one yet knew why. Behind the scenes, the error was quietly building. Lockheed Martin's software, used to calculate the spacecraft's thrust, produced data in pound-for-seconds, an imperial unit. NASA's navigation software, however, expected the data in Newton seconds, the metric equivalent. The difference between the two? A factor of 4.45. Every time the spacecraft adjusted its path, it believed it was making a gentle correction. In reality, each burn was 4 times more powerful than expected. Bit by bit, the trajectory drifted lower and lower. On September 23, 1999, the Mars Climate Orbiter prepared to enter orbit. Mission Control watched closely as the spacecraft disappeared behind Mars for its orbital insertion. They waited for the signal that would confirm success. Minutes passed, then hours. The signal never came. The orbiter had descended far too low, just 37 miles above the surface instead of the planned 93 miles. At that altitude, the thin Martian atmosphere tore the spacecraft apart. NASA had lost contact forever. An internal investigation later confirmed the cause: a failure to convert imperial units to metric units in one line of code. It was a small mistake with enormous consequences. The disaster cost more than $300 million, and it became one of the most expensive lessons in engineering history. NASA immediately revised its software integration and testing procedures. From that point on, every inter-team data exchange required explicit unit verification and documentation. The Mars Climate Orbiter is now remembered as a symbol of how fragile precision can be. It's a reminder that even brilliant engineers can be undone by simple human assumptions. Because in space, every detail matters, even the units you measure it in.